100 derivatives, and we'll be doing them in one take. However, this is not the first time doing this though, because I actually did this 10 years ago already. But let me tell you guys this first. I would like to dedicate this video to all my upper bound students, especially the ones in 2009 in the summer at UC Berkeley campus. And let me tell you guys, my upper bound students, I still remember everyone. I still remember you guys. It was such a wonderful experience that we had. And that was the second time that I had my own class. I taught my own calculus class during the summer. And upper bound, it's a program that helps high school students who are from low-income family, just like myself as well. And I, of course, have to thank my director, my main man, Mr. Nomiga Lamimba. Thank you so much for believing me. Thank you so much for giving me so many chances to teach the class. I tell you, of course, I cannot be quiet today. I cannot thank you enough. Thank you. Alright, so 10 years ago, I actually did a PDF because I was teaching my class, right? And I decided to produce, enough examples for my students. And how many examples are enough? It came up with 100 derivatives, questions, and also solutions. And type them up. You guys can find the link to the PDF. I will have that in the description for you guys. But today, though, we'll be doing something different. I have this right here for you guys. And notice that the questions here, they are in the multiple choice format, because I believe it's the best when you have derivative questions with multiple choice format, because sometimes you don't know how much more you have to simplify or how much more you have to keep going or when to stop. So multiple choice format is the best for derivative questions. And for the people who would like to know this, yes, of course, how can we have derivatives without the definition, right? So if you guys would like, the last 10 questions or so, yes, derivative by using the definition. But the first 90 question will be just, we use the rules that we have known already, okay, all that. So this is going to be good for part 1 and part 2, and hopefully you guys will enjoy this. And in fact, today I have something fun. Let me just show you guys this right here. I bought this recently. Right? I bought this recently. I opened it. This is called the Ninja Milk, M-E-L-K, Ninja Milk from Ryan Higa. And I'll be trying his energy drink for the first time. So just to see, I have this package right here. Right? So I haven't opened the package yet. So I will show you guys how it is, but not now, because right now I have enough energy, so I don't need it. Yes. I don't know how long it will take me though, so I don't know how many I'll be drinking, so I don't know. And of course, I have my Verizon medal. This is the one from 2007, and P artist, meaning personal record, playing this year. And you might be wondering why don't I bring the one from 2009. Unfortunately, I didn't run that one in 2009. Alright, anyway, you guys can find the PDF in the description right here, right? So, yeah. Alright, here we go. First question. We are going to be differentiating a squared plus bx plus c. Notice that a, b, c are just constants, right? So, for the first one, let's just start something easy. It's just a power rule. And the idea is that whenever you're adding or subtracting, right? But this is just all adding. You can just differentiate the first, and then differentiate the second, and differentiate the third, and then just put the results together. That's it. So for the first one, for this right here, I will just bring the 2 to the front, and then minus 1. That's the rule called power rule, right? So the first term we'll get 2a, and then x to the first power. You don't have to put on 1. And then the next one is plus. When we have b times x to the first power, well, we can put on the 1 right here. We can bring the 1 to the front, and then minus 1. 1 times b is just b, and the x to the 0th power is just 1. So it's just b. It's just the coefficient of x. Lastly, this right here is just a constant. So when you differentiate constant c, when there's no x, the derivative is just going to be 0. So you don't even have to put that down. So for the first one, the derivative of a quadratic is just 2ax plus bx. That's it. Start with something easy, right? And I'm not going to give you guys the answer key. Hopefully you guys can all figure this out. So there's a nice pattern. You just can let me know in the comment down below. Let me know about the pattern. Anyway, second one, we'll be differentiating sin x over 1 plus cosine x. Notice that this is a quotient, and we'll be just using the quotient rule for this. So here we go. Before we forget, let's go ahead and square the denominator. So we will have 1 plus cosine x, and we'll raise that to the second power. And then the quotient rule says we will have to put the denominator to the top right here. So let me just write down 1 plus cosine x. And then we multiply by the derivative of the top. The derivative of sin x is just going to give us cosine x. And of course, you have to know all the derivatives of the functions, right? Yeah, so you have to know that. Alright, so you have all this, and then you have to subtract the top function, which is sin x. And then multiply by the derivative of the bottom function. The derivative of 1 is 0. The derivative of cosine x is negative sign. So we have negative sign right here. And now this is the time that you have to think about how we can simplify all the expressions right here. Well, of course, we can just distribute the top right here. So we'll do that. So cosine times 1 is just cosine x. Cosine times cosine is cosine square x. And we put the power 2 right here, right? Cosine x and then square. And then negative becomes positive. And the sin x times sin x is of course just sin square x over the denominator right here, which is 1 plus cosine x squared. And now, check this out. Here we have cosine square x plus sin square x. Guess what? Yes, we can use a nice trick identity for this. This right here is nicely equal to 1. So we just have a 1 right here. In fact, on the top we have 1 plus cosine x over 1 plus cosine x. just write it down here for you guys to make it clear. This is, let's say, 1 plus cosine x. And then we divide it by the bottom is parentheses 1 plus cosine x, and then to the second power. So, of course, we can cancel this one out with 1 of it on the bottom. And therefore, all in all, the answer is just 1 on the top over 1 plus cosine x to the first power, like this. And after that, we are done. We don't need to put down the plus c because this is derivative. This is nothing to do with integration. Right? So, find the answer in the answer choices right here. Alright, number 3, I will also fill in here, right here. So, we will be differentiating. It's just the flip of this. This right here, we have sin x over, Number 3, I should have written this down earlier. Number 3, we have 1 plus cosine x over sin x, like this. Well, for this question, in fact, we don't have to use the quotient rule because we only have one thing on the bottom. And we have 2 things on the top, right? 2 terms. We can just split the fraction. It will be easier this way. So now check this out. I'm not doing derivatives yet. I'll just put down d dx to mean that we will be taking derivative and we'll split the fractions. 1 over this, 1 over sin x. And then the second one is plus cosine x over sin x. And then, of course, 1 over sin x. Do we know anything about that? It's right here. Yes, it's just cosecant x. Likewise, this is just cotangent x. So check this out. This right here is just to differentiate. We haven't done the derivatives yet, so we still have to write this down. We have to differentiate. This is cosecant x, and we will have to add the result with this right here is cotangent x, like this. Oh my goodness, I will have to remember what the derivative of this and that are. I think I know. The derivative of cosecant x is negative cosecant x times cotangent x. And then the derivative of cotangent x is negative cosecant x squared, where you put the 2 right here, right? And that's it. You don't have to factor out the cosecant x, and you can find the answer in the answer choice right over there. So that would be good. I just realized I made a typo on my answer choice. And I'll fix that later, but yeah. So yeah, if you guys saw the answer earlier, but just look at the file in the description. I'll fix that before I post it. So anyway, these are the first 3 questions. I don't know how long it will take me. Derivatives usually aren't so bad until we hit the definition, right? When we have to prove the derivative of what was the definition of derivatives. Alright, so 3 questions down, and many more to go. And hopefully you guys all find this video to be helpful, right? Alright, number 4, we have the square root. Right? So here we have number 4. We will have to differentiate the square root of 3x plus 1. The derivative of square root of 3x plus 1. Now, this is how we can do it. First thing first, you have to know, right? You have to know that the derivative of the square root of x, like this. This right here will happen a lot, so you just might as well remember it. The derivative of square root of x is 1 over 2 square root of x. And to do this, you will have to write the square root as the 1/2 power, and you bring the power to the front, and then minus 1 from the power. So you end up with 1/2 x to the negative 1/2. X to the negative 1/2 is the same as putting the square root in the denominator. As I said, you should just remember this and then use that to do the questions like this. So here we go. To differentiate the square root of 3x plus 1, we will just have to look at the big picture, which is the square root. We will have to do 1 over 2 times the square root of the inside, which is 3x plus 1. Right? It's pretty much the same idea over here. However, don't forget the chain rule. We have to multiply by the derivative of the inside. The derivative of 3x plus 1 is just a 3, so you multiply by 3 right here. Right? So this is the chain rule. And some textbooks, they like to call this step the chain rule. So one way or the other, they both work pretty nicely. In the end, of course, 1 times 3, you can just put a 3 on the top, so 3 over 2 square root of 3x plus 1. And guess what? We are done. So this right here is it. Alright, now, number 5. So here we have d dx. This again means to take the derivative, and we have these 2 notations. Sine, and you put a 3 right here of x. And then we add sine x like this. With a 3 right here, parentheses, and technically I also have a parentheses right up there. Here is the deal. This right here, right? This right here, it means we will have sine x, right? Raised to the 3rd power like this. And then of course we will have to differentiate this guy, right? So it's just the notation. Whenever we have the 3 right here, it means we have sine x times sine x times sine x. Of course we write it like this, right? But when we have sine of x to the 3rd power, this means we have sine of x times x times x, like that. Parentheses matters. Parentheses matters. They are totally different. Be sure you are familiar with the notations, right? So this is how I would recommend you guys to do these questions. We have technically 2 questions to do, right? 2 parts. Alright, here we go. We have to differentiate. For the first one, that's right here sine x to the 3rd power. And then for the second one, I'll just keep it like this. Just remember to use the chain rule times whenever we need to. Okay, here we go. For the first one, sine x is the input, and then we have this raised to the 3rd power. So do the big picture first. Bring the power to the front, and then minus 1. So we end up with 3 parentheses. And the inside stays the same for now. So just write down sine x. And then 3 minus 1, that's a new power, which is 2. And now it's the time to use the chain rule. You look at the inside, which is sin x. And you ask yourself, what's the derivative of sin x? Which is just cosine x, right? And you multiply this part by cosine x. This is the chain rule. And then right here, let's go ahead and add. For this part, well, this time though, the big picture is sine of this. So, to differentiate sine, which is cosine, and the input is x to the third power, it stays the same right here. Okay? And then we look into the parentheses. The derivative of x to the third power is what? Well, it's 3x squared, right? Just use the power rule, so you get 3x squared. So this is it, right? This is it. And finally, we'll just write this down the usual way. So here we go. I will put down the 3 right here, and I will put down the cosine first. Yeah, put that down. No, I didn't put down the cosine first. I will just write it down. This right here is the same as saying sine with a 2 right here, right? And then the cosine x. And for this one, usually we put the polynomial part in the front, so I will write this down first, which is the 3x squared times cosine of x to the third power, like this. And with that, we are done. This is going pretty well, unlike the integrals. So this is number 5. Okay, number 6. I will just put it down right here. I will see this is a little bit so I can. Number 6. Here we go. We have to differentiate 1 over x to the 4th power like this. Okay, so x to the 4th power. This is easy, huh? So of course we can just look at x to the 4th power, bring the 4 to the front, which is just 4x, and then minus 1, which is 4x to the 3rd power, and that's in the denominator, just like that, right? No, don't do it like this. No. This is not the answer. Not the answer. Why? Because the 4 that you see right here is not really a 4, because it's in the denominator. Therefore, this right here is really asking to differentiate x to the negative 4th power. In order for us to use the power rule, remember, we have to have x to some number, right? Well, 1 over x to the 4th power, unfortunately, this 4 is actually a negative 4th power, so you have to know the rule of exponent really well. This is very similar to the square root example. You have to write the square root with 1/2 power. Anyway, look at this right here, and then do the power rule. Bring this to the front, and then minus 1 right here, and we end up with negative 4 times x to the negative 5 after you subtract them, and that's pretty much it. Finally, negative 5, that's the power for the x, so we can bring this down to the denominator. Therefore, we end up with negative 4 over x to the positive 5 power, like this. So this right here is a true answer. This right here is a common mistake. Don't do it like that. Right? Don't do it like that. Right. Continue. Number 7. Here we are going to differentiate, and we have 1 plus cotangent to the 3rd power. Cotangent x and then to the 3rd power, like this. Right? So here we go. Of course, we have inside and then raise to the 3rd power. So again, we have to do the big picture first, which is the outside power rule, right? Bring the 3 to the front and then minus 1. So here we go. Bring the 3 to the front. Inside stays the same. Just write down 1 plus cotangent x. And 3 minus 1 is 2, of course. We're not done yet though. Look at inside and ask yourself, what's the derivative of 1? Which is 0. What's the derivative of cotangent x? Well, that's negative cosecant squared x. Remember the chain rule, right? And of course, this right here looks like subtraction, so be sure to just put up parentheses. This is the derivative from here, and we have to multiply this with that. This right here is pretty much it, and in the end, we just have to write it down nicely, put a negative all the way in the front, that's all. So finally, we have negative 3 times this, which is 1 plus cotangent x, and then square, and then in the end, I have the CSC squared x, which is the cosecant squared x. Just like that, and that's it. Alright, now, number 8, I need more space, so I will have to erase this now. So the first couple questions, I think the first 20 questions are more like warm up, and I put it like according to the difficulty and also the things that you have to know in the usual order. Each time you'll see the inverse trig functions, natural log, exponential, and hyperbolic functions, all that stuff. Alright, now things are getting slightly trickier and also slightly more complicated. Anyway, here we go, number 8. We are going to differentiate, let's see, x squared times 2x to the 3rd power plus 1 and raised to the 10th power like that. Alright, this one, compared to the earlier one, well, we have x squared right here times this quantity to the 10th power. So it's not just a simple chain rule question, because right here, we will actually have to use the product rule, because we have x squared times this. And this is how I like to set up the power, this is how I like to set up the product rule for my students for the first. I'll show you guys at least one time during this video. So, here we go. Well, this right here is the first function, so I'll just write down x squared, and I will call that to the f. And this is just the first function, x squared, like this. And this is the second function, so it's g, which is 2x to the 3rd power plus 1 to the 10th power, like that. Well, separate this, and I will differentiate them individually. For the first one, the derivative of this, which is just 2x. And then the derivative of this is g, right? So g prime is going to be the following. The derivative of this, of course, we bring the 10 to the front, minus 1, and we get 10, and the inside stays the same, 2x to the 3rd power plus 1 to the 9th power, like that. And then we multiply by the derivative of the inside because of the chain rule. The derivative course, we can simplify this a little bit. 6x times 10 for 16x, and this is 2x to the third power plus 1 to the ninth power. So you can just set it like this, and then we just kind of cross multiply to construct our answer. Product rule in action, f times g prime. So we will have x squared times this, right? So let me just put this down here, which is 16x times 2x to the third power plus 1 to the ninth power. And then we go the other way, which is this times that. We add this times that, which is the original in blue. We have parentheses 2x to the third power plus 1 to the 10th power, and we multiply by 2x. So this is the right out, right? By using the product rule and also the chain rule. So you just have to do it carefully. And later I'll show you guys without these things, right? But I think this is helpful, especially if you're doing the relative effective calculus for the first time. Alright, in the end, we just have to simplify this. Let's see. First of all, we notice that both terms, they have this factor, right? 2x to the third power plus 1. And this is ninth power, and this is the 10th power, so we can factor out the smaller exponent. So perhaps let's do that. And in fact, we can also factor things out. This right here is 2x. And this is 60x. Both of them have x, and both of them have a factor 2. So perhaps let's do this first. Let's put down the factor of this, right? So let's factor out 2x, and let's factor out 2x. Okay. In the meantime, we can also factor this out, which is 2x to the third power plus 1 to the ninth power, like this. And now let me show you what the leftover is. Well, if you look at this part, we factor the other 2x, so 60 divided by 2 is 30. This x is out, but we still have x squared, so we write down x squared right here. And in this part, we factored it already, so this is all we have, namely 30x squared. Now, if we look at this part, first we have to add. Notice the 2x is all the way in the front already. And then for this part, we see we took out 9 of the factors already. That means we have one more. So we just have the inside, which is 2x to the third power plus 1 to the first power, just like that. And in the end, I just kind of did it like that, I think. Yeah, I didn't do anything. Ah, no. No, I made a small mistake. Man, okay. 2x to the third power, the derivative 2x to the third power is 6x squared, like that, right? And then this right here should have been a 60x squared right here. 60x squared right here. And let's see. So this right here should have been 60x squared. And let me just do this part here for you guys. Alright, so 60x squared. Right here. Again, same thing. We can factor out the 2x, right? So we can factor out 2x. Let's do that. And we can also factor this out, which is 2x to the third power plus 1 to the ninth power. And now, actually, I'll put this down blue. So I'll put it down blue again. Anyway, 2x to the third power plus 1, and then to the ninth power. And parentheses, you see I make mistake too. Parentheses, okay, for this part, again, we took out the 2, so we have 30. And then we took out x. So this right here is just x to the first power. X times x squared, though, is x to the third power. Again, because this right here is x squared, so it's x times x. So we took out one of them, you have another x. This x times x to the second power, we get x to the third power. Alright, and then that's it for the first part, because this is out. For this part, this is out. We have this left to the first power, so we add 2x to the third power plus 1 to the first power of this. In the end, we can combine this and that together, so we'll do that. And finally, we see the answer is my equal sign. Here we go. The answer is 2x times 2x to the third power plus 1 to the ninth power times this plus that, which is 32x to the third power, and in the end, we have the plus 1. And that's it. So it simplifies pretty nicely, right? And yeah. Alright, now number 9. By the way, it took me a lot of time to come up with answer choices as well, not just the question. I want to make it rather legitimate. I can just give it to my students for them to practice. And for the actual example, actual quiz that I give out to my students, I usually have 5 or 6 answer choices, but this is just for practice. That's why I only have 3 choices. Anyway, number 9. Here we go. We have this. We have to differentiate x over, and the bottom here is parentheses x squared plus 1 to the second power, like that. Well, why don't I show you guys this right here as well? I call this the memory device whenever we have to do the product rule, quotient rule, and chain rule and all that. Especially if the question is complicated, I like to show my students this, especially for the first time. Anyway, here we go. This right here is a quotient, x over this, right? So we have to use the quotient rule. And the quotient is just the opposite of the product. So what you do is, on the top is the f function, on the bottom is the g function. Well, earlier you see the first one is f, the second one is g. Well, for the quotient rule, we actually write down g first, and then f right here. So the g function is this, which is x squared plus 1 to the second power. And then the f function is just x on the top. Once we put them down individually, we can just differentiate them individually. For the first one, we will just get g prime. And this is going to be, okay, put it to the front, minus 1. And we'll get 2 parentheses x squared plus 1 to the first power. And we multiply by the derivative inside. Because of the chain rule, the derivative of this is 2x. So just like that. Well, for this one, of course, differentiate this real quick, we just get 1. So that's pretty nice.